Welcome back, students. So in our previous lecture we have seen how to fit Horton's equation, and I have shown you how to fit the Horton equation through manual calculation, as well as I have also shown how to do it graphically using a spreadsheet program. In examination, however, you will not be provided with any spreadsheet program, so you should be learning how to use a graph paper to derive the parameters. So here in this lecture we'll be discussing the part B of the question, which states which even asks us to find the model parameter of the form f is equal to a t to the power n, where f is the cumulative infiltration. Here f is measured in mm. So to avoid the confusion with the previous one, I'm just writing this as FC. So to differentiate that this is the cumulative infiltration. It is not infiltration rate, it is infiltration. So how we go about with this is, and also one more information, this equation is what we call by Kostyov equation, okay? K-O-S-T-I-A-K-O-V, Kostyov equation, okay? So this is in the form of Kostyov equation. Okay, similar to the previous one, first we start by writing the equation f is equal to a times t to the power n. Okay, so where a and n are the model parameters, and let's take the logarithm on both sides. So ln of f is equal to ln of a plus n ln of t. So if you closely look this equation, it is in the form of y is equal to mx plus c, where ln f is the y, okay, and n is the slope, and the ln a, okay, parameter ln a is the intercept, 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 and the variable, the independent variable, okay, the independent variable is ln of t. So what we need is, for our computation, what we need is we need to plot a table. We need to in fact the values, we need the values of ln fc. Okay, so I said I'll be writing fc, right? So let me replace this f with fc, and we need ln of t. And also we know that this ln of fc is the cumulative infiltration. Okay, so with this, let's quickly tabulate our values. So the information provided to us is, let me write it down, t is provided to us 0, 5, 10, 15, 25, 45, 60, 75, 90, 110, and 130. And in our previous calculation we have already calculated the value of infiltration, right? So I'm simply writing that infiltration as let me put it as infiltration as I. This is in a form of, it is measured in mm. So for the first, it was nothing was recorded. Second, it is 17 mm of infiltration was there at the first 5 minutes. Okay, likewise 13, 10, 15, 22, 15, 15, 15, 20, and 20 mm was recorded. Now for this we need the cumulative infiltration. So here I'm writing this as FC. Okay, that is cumulative. Okay, so it starts with dash. First is 17. Now 17 plus 30. Okay, it is 30. Now 30 plus 10, it is you need to add these values. Okay, so let me do it this way. So you need to add this value. Now you need to add this value. It's going to be 40, and then 40 plus 15 is going to be 40 plus 15 is going to be 55. Okay, so likewise is going to be 77. 77 plus 15 is going to be 92, plus 15 is going to be 107, plus 15 is going to be 122. Likewise plus 20 is going to be 142, and lastly plus 20 is going to be 162. So this is the cumulative infiltration. Now from our equation here we need few things. We need ln of FC and we need ln of T. So that is what I'm going to tabulate here. So ln of FC. Okay, so here is going to be dash. There's going to be ln of 17, which is going to be 2.833. Here ln of 30 is going to be 3.401. Likewise ln of 40 is 3.689. ln of 55 is 4.507. ln of 77 is 4.344. Likewise ln of 92 is 4.522. 107, ln of 107 is 4.673. ln of 122 is 4.804. 4 point next is 4.956, and lastly the ln of 162 is 5.088. okay, now next is we also need ln T. So for the first value is going to be ln of the first is dash, next is ln 5 is going to 5 by 60. okay, we need to do it in hours. So 5 by 60 is going to be minus 2.485. likewise ln of 10 by 60 is going to be minus of 1.792. here ln of 15 divided by 60 is going to be minus of 1.386. likewise here is going to be ln of 25. ln of 25 divided by 60, I'm simply converting this time which is given in minutes into hours. So the value is minus 0.875. So now I'm simply going to write the values here. Okay, ln of 45 is minus 0.288. Next is 0. Next is 0.223. Next is ln 75. So ln 90 is 0.450, 0.450, and ln of 110 is 0.606. Lastly, ln of 130 is 0.773. So what I said is this is in the form of a straight line. So this equation, I said it is in the form of a straight line. So if I plot the ln fc versus t, I should be getting a straight line. Okay, so I should be getting a straight line. So if I plot a value of ln of fc versus ln of t, I should be getting a straight line with a positive slope. Okay, and that's it. So the value that we have to note from this tabulation is, the first thing that we need to calculate is the slope. Okay, so slope is delta y over delta x, so it's equal to, so I'm simply taking the last values, okay, first and the last value. All right, so the first value is 2.833 and the last value is, so let me highlight the values that I'm going to take. Okay, so I'm going to take these values. This is the first value, correspondingly the ln t is this. I'm going to take the last value and corresponding time is this much. So I'm going to take these 4 values to calculate the slope. Okay, so let me minimize my screen so that everything is visible on the screen. Okay, so delta y is 5.088 minus 2.833 divided by delta x. So delta x is 0.773 minus delta x here means whatever the value is plotted in x-axis, so time is plotted in x-axis, so that's what it's mean. Okay, minus of 2.485. so this is going to be our value. So here let me quickly go to calculator, and so okay, I'm here at my calculator. So the first value is delta y 5.088 minus the first value is 2.833, close the bracket, fraction 0.773 plus 2.485. Yes, so the slope is how much? 0.692. 0.692. We got the slope. Okay, but we need 2 parameters. One is slope, another one is the intercept. We need this value. If I extend this line, I need this value because that is what intercept means. This ln a, I also need to calculate the value of a. A is intercept. So conceptually, intercept means value of y when x is 0. So what you do is you check this column, t column, ln t column, and you go to the value where it is 0. Now if there is no 0, then you have to do the interpolation. So right now the value of 0 is bilevel, so we will simply correspondingly take this value. So that is going to be the intercept value. Okay, So intercept simply means the value of y when x is 0. So value of y is this much. So intercept, so this is slope. Okay, now intercept is ln of a is 4.522. So what's a is the Euler number e raised to power 4.522. so that is our value. So let's quickly calculate this. 4.522, so that is the number 4.522 e raised to 4.522, so it's going to be 92.019. So 92.019. so our main equation is FC is equal to A is 92.019, right? T raised to the slope is 0.692. so we have fitted the model. So now what we can do is we can go over to the spreadsheet and try to do the calculation again and prove that whatever we have calculated is correct. So with this, I would like to end this portion here, and let's switch over to the spreadsheet program. Welcome back, students. So here we are at the spreadsheet program, and I have already made the table with necessary values. If you notice, the time I have already converted into hours. Okay, although it was not necessary, but I wanted to keep the unit consistent like in our previous calculation. So infiltration depth is what we have already calculated, so I have tabulated it here. So now let's calculate the cumulative infiltration. So for the first, it's going to be 17. Next is going to be 17 plus the next value, right? So it's going to be 30. So let me just scroll this. So we have the cumulative infiltration. So like I said, we need ln of t, and we also need ln of fc. So let's quickly calculate these values. Equal to ln of time. Okay, so this is going to be this much. I'm simply going to drag. Okay, so here is going to be ln of the cumulative infiltration. So it's going to be this much. Okay, so we have it here. All right, so like I said, if we plot a value of ln t versus ln fc, ln t in x-axis and ln fc in y-axis, then we are going to get a straight line. So let's verify that first. Insert. Before that, it would be interesting to see the cumulative curve. So cumulative curve, in my lecture session, I have shown how the cumulative curve looks. So before that, before we go further, let's see the cumulative plot, and then let's go ahead with the calculation. So let's calculate. Let's see this. So right now I'm going to delete this, okay, because it is not required. I just wanted you to see what this column means. So you already know that f is the infiltration depth and fc is the cumulative. So I'm going to get rid of this. Okay, so now it's fine. So let's plot a value of this with this one and see what kind of shape curve we get. So I don't want this, I want this type of curve. So let me minimize this a little bit so that you can see it better. So as you can see, this is the shape of the cumulative curve, and it somewhat resembles the curve that I have shown you in the lecture. So okay, so far so good. So let's get rid of this curve, we don't need it, and let's plot the curve between ln t and ln fc. So insert chart. I don't need this, I just need X, Y, and let me minimize this plot. Okay, so now you see this. I said this line has to be it has to be straight line, right? So judging by the line, it seems it is a straight line. So okay, so let's fit a trained line and get our values. So insert train line, linear of course, and show the equation, and don't force any intercept. We need the intercept value, and the variable is ln t, if you remember, and that is going to be our y, right? That is going to be ln of fc. So that is the independent variable, and this is the dependent variable, and this is the independent variable. By the way, I'm using LibreOffice. This is not Microsoft Office, okay? I'm using LibreOffice, so I am not sure whether you can do this kind of manipulation in Microsoft. This LibreOffice is free and you don't have to pay anything, so that's why I use this. Okay, so here we have the equation. So what does this equation says? The equation says the slope is 0.664, okay, and the intercept value is 4.551. so intercept is 4.551. all right, but we need to understand that this is both sides, it is ln, right? So we need to convert this into our normal. So to convert this intercept a, right, normally we represent the equation in the form of f is equal to a t to the power n. So let me see whether it okay, in this form we need it. So a here, so ln of a is equal to 4.551 as per this equation, right? So the a value is going to be e to the power of 4.551, right? So let me put this to power, Control Z, Control Z, what is going on? Control P. Okay, so a is this much, so let's calculate the value, which is equal to exp of this value. Great, so this is our value of a. So let's fit the equation now. So like I said in my previous video, you are trying to fit an equation to already existing data. So modeled equation and the real data, there should be some, there should not be much a deviation. So we have to check whether there is a deviation or not. So what I'm going to do is, let me first write down our equation. So f is equal to 94.727 times t raised to power of n. N is 0.664. that is the slope, right? So let me put it to power. All right, so we have this equation. So what I'm going to do next is, let me, okay, so this is time, so this is the actual, and let it be the modeled. So modeled one. So actual, I'll simply have to bring this value. Okay, so I'm going to copy this and put it here, paste it here. So this is the actual value, and model value is going to be how much? This is the equation, 94.727 multiplied by time raised to 0.664. so this is the model one. So here it is. So it is not deviating much for the first value, at least. Yes. Okay, did I make some mistake while copying? I think I made some mistake while copying this value. Okay, I should copy this value as values. So copy this and paste it as numbers. Okay, now it looks fine. So let me highlight this, because control cut this and put it somewhere here, so that paste it. Okay, so this is our calculation, and like I said, these actual and models should not deviate much. Okay, so let's see, and let's plot this graph, and then only we can see whether it is deviating or not. Insert chart. I don't want this, I want this. Okay, so let me minimize this a little bit so that you can visualize this better. All right, let me drag it to the screen. So you can see this. Actual is this one, modeled with Kostyukov equation is the orange one. So it is somewhat, it is almost, it's better than hot run, right? So from the previous experience, we have seen the hot run was underestimating for the initial values, but here it is not underestimating. So it is somehow, it is able to trace the original data. So this is it. So that is the meaning of, in fact, the modeling. You are trying to replicate the original data with some equation, and the equation parameters a and n we have calculated it. And it would also be interesting to compare what we calculated manually, right? So manually, let me put it here. Okay, so manual, so this is slope, and this is graphically, we are calculating it. Paste, and this is manual. So manual, how much we calculated? Slope 0.692, fine. And value of ln A intercept was, we simply took out that value from the table. That was how much? 4.522, and the value of A that we have got is 94.72. 92.019. So this small deviation is because, you know, it's a power, right? So even the third decimal places also affects. So you can see there's no much of difference between what we have calculated it graphically and what we have calculated graphically and manually. So it works both the way, but the concept should be clear. Okay, so with this, I would like to end the lecture here, and I would really appreciate if you can do this calculation yourself, plot this graph yourself. Of course, it is important to learn the spreadsheet, but also you have to learn how to do it on a normal graph paper. Okay, so